Okay, on this video, I'm going to go through 30 through 44 on the final exam review. Here's what we got. For questions 30 and 31, identify the domain and range. We got doctor, XY, and don't forget robot, dealer. Oops. Oh my gosh, y'all. I haven't even had lunch. I've been trying to fix this video. Okay. If you have a bunch of points, this is called, as a reminder, it's called discrete. Discrete is dots. If you have discrete data and they are dots, what you have to do when you're making your domain and range is you make a list. Okay, so my domain. With this weird squiggly bracket thing, don't judge. Well, for this point, my x is -5. On this one, my x is -2, so -5. We got -2. We have 0, 1. You get those 2, 0, 1. We have here 4, and we have 9. So there is my domain. If it's dots, you just make a list. For my range, we go from bottom to top. Well, the lowest I can go is -9. For this one, the next one's at -6. This one's at -4. This one's at -3. This one's at 0. And this one is at 5. I feel like I went really quick on that. I'm so sorry if I went too fast. All right. Over here, remember if it's connected, if it's all like a line, that's called continuous. That's when we make our inequalities. For my domain, left to right, the furthest left we can go is at -4. The furthest right we can go is at 6. So I'm going to write down -4 and 6 with the next in the middle. Less than and less than. Close my bracket. If it's an open circle, we leave it alone. If it's a closed circle, like on this one, it's going to be or equal to. Okay, for my range. Range, we do bottom to top. The lowest we can go is -9. So I'm going to write that down. The highest I can go is not at this point because we want the highest we can go is at -1. So I'm going to write down -9, write down -1, put y in the middle, put my less than and my less than. At -9, we have a closed circle, so it's going to be or equal to. At -1, we also have a closed circle, so that one's also or equal to. Okay, sliding down here. Yes, technically you can solve these by hand. We don't got time for all that. We're going to solve some of them. We're going to solve like 3 of them by hand. If you have an equal sign, plug it in row 1, row 2 in your calculator. So box both sides, plug in your calculator. Y equals 15 plus 6x. Y equals 45 plus 8x. So plug in the left side of your equal sign and the right side of your equal sign. Go see where they cross. Ignore that. I'm trying to fix the other video that didn't work. Okay, let me clear all this. So y equals 15 plus 6x, and y equals 45 plus 8x. So here's my 2 lines. I'm going to click on the gear and then click on the circle. If I have a black line, I'm going to change it to blue. Nothing wrong with the color black, but it makes it a lot easier to see on the graph. I'm going to go look at where they cross. Well, you can tell going towards the bottom is where they're getting closer. So I'm going to go, go, go. Tap with my finger literally on the screen where I think they cross. And a dot will pop up. These cross at -15, -75. My answer is the first number. X equals negative 15. So now I'm going to do the same thing here. Even though it's a lot longer, here's my equal sign. I'm going to box the left side of my equal sign and write it as y equals 10x minus 4, parentheses x minus 2, and then y equals the right side of my equal sign. 12x plus 7, parentheses x plus 3. And I'm going to go see where those two cross. So y equals, this is 10x minus 4, parentheses, x minus 2. And then here y equals 12x plus 7, parentheses, x plus 3. Here's my two lines. I'm going to go and look and see where they cross. They're getting closer, getting closer. Tap where I think they cross, and then click on the point. Our answer is our first number, so x equals negative 1. All right, same thing on this one. Even though it has fractions, we box the left side, write it as an equation. Y equals 2/3 x minus 4. Box the right side, write it as a y equals 18 minus 1/4 x. Plug it in, row 1, row 2. Go see where they cross. So y equals 2/3 x minus 4. Y equals 18 minus 1/4 x. Click on where they cross. My answer is the first number, x equals 24. Okay, for the inequalities, we have to solve these by hand because we got to be careful on it. So, here's what we're going to do. First thing we do is take care of parentheses. We're going to multiply. 6 times x is 6x. 6 times 3 is 18, so plus 18 is less than or equal to negative 2x minus 62. So if we have an inequality, we're going to, whoa, I just flipped the whole thing. I meant to zoom in. We're going to solve it by hand. Okay. Now that I've done that, we circle our x and do opposite operation. If I want to get this x by itself, what's the opposite of plus 18? Minus 18. So minus 18 to both sides. So we got 6x is less than or equal to negative 2x. If I'm not sure what this is, I can always plug it in my calculator. I'm going to do negative 62 minus 18. I get negative 80. Minus 80. Okay, so we did the opposite operation. Now I need to get my x over here. We want our x's on the same side. The opposite of minus 2x is plus 2x to both sides. We have 8x is less than or equal to negative 80 because those canceled out. Last step, we need to divide both sides by 8. If you divide by a positive number, your inequality sign does not flip. So we're going to have x is less than or equal to negative 10. If you divide by a negative number, then it would flip. Okay, so I'm going to try another one. Draw my line of balance. On this one, there's no parentheses, so we don't have to worry about multiplying. We're going to circle our variable and do opposite operation. The opposite of plus 14 is minus 14 to both sides. So I have 1/2 x equals 5/3 minus 21. Now I need to get my x on the left side. Oops, don't let me put less than, y'all. That's this is less than, not equals. So 1/2 x is less than 5/3 minus 21. Well, the opposite of positive 5/3 is minus 5/3. Oops. So let me plug that in. 1/2 minus 5/3. 1/2 minus 5/3. I'm going to change it to a fraction just because that seems nicer. Okay. So we got -7/6. So we have -7/6x is less than -21. Well, we don't want -7/6x, so we're going to divide. I'm going to write over here because I ran out of room. -7/6x is less than -21. Divide both sides by -7/6. Because we divided by a negative number, this sign in the middle flips, so it's going to be greater than. X is greater than, I'm going to plug that in. I'm going to clear all this out. What time is it? I'm doing good. Okay. -21 over -7 divided by 6, which is 18. So x is greater than 18. All right, sliding over to 37, line of balance. First thing I'm going to do is multiply so I can get rid of those parentheses. 2 times 5 is 10x. 2 times -1 is -2. Is greater than or equal to 3 times x is 3x. 3 times 11 is plus 33. Circle our variable. Opposite operation. The opposite of -2 is +2 to both sides. So we have 10x is greater than or equal to 3x plus 35. Yes, okay. Yes, yes, yes. Okay. Now I need to get our x's on the left side. The opposite of a positive 3x is -3x to both sides. 7x is greater than or equal to 35. Divide both sides by 7. Because we divided by a positive number, our sign in the middle does not flip. X is greater than or equal to 5. Okay. For number 38, we are solving for w. We need to get that w by itself. So we have, if something is squished together like that, that means they are multiplying. So we have right now basically v equals the length times the width times the height. That's what's happening here. We need to get this w by itself. We're going to do opposite operation. So what's the opposite of multiplying something? Dividing something. Oh, there went the lights. Okay, so the opposite of multiplying something is dividing it. So we're going to divide both sides. Well, I need to divide it by L because the opposite of times L is divide by L. I also need to get rid of this H. The opposite of times H is dividing by H. And if I do it on one side, I have to do it on both sides. My lengths cancel, my heights cancel. So we have W equals V over LH. And that's it. That's done. There's no simplifying happening here. All we're trying to do is get W by itself by doing opposite operation. Sliding over to 39, solve for H. So what we have here is area equals your base times your height divided by 2. We need to get H by itself. We do that by doing opposite operation. Right now we're dividing by 2. So what's the opposite of divide by 2? Multiply by 2. And if I multiply one side by 2, I have to multiply both sides by 2. Our 2's cancel. We are left with 2a equals base times height. We still need to get h by itself. Well, what's the opposite of multiplying by b? Divide by b. Because if I do it on one side, I do it on both sides. The b's cancel. So we're left with our height equals 2a over b. Okay. For number 40, y'all, this is a calculator question. Plug this in the first row of your calculator. Plug this in the second row of your calculator. row 1, row 2. Literally exactly how they said it. So, go in here. They told me f of x equals 16 minus 2 over 3 x, and we're trying to find f of negative 6. My answer is right here. They told me it is 20. All right, sliding over here. Same thing. We're going to plug this whole thing into the first row of my calculator. Plug this into row 2 and go see what my answer is. So this one is f of x equals 3 parentheses x minus 4 plus 10. And they told us we're looking for f of 2. My answer is 4. All right, flipping over to the back. Okay. So graphing inequalities. Couple things we need to know. First of all, as a reminder, if it's less than or equal to or greater than or equal to, it's going to be a solid line. Solid. If it's just less than or just greater than, it's going to be a dashed line. If it is less than, or if it is less than or equal to, less than or less than or equal to, you're going to shade below. If it is greater than, I know I'm blocking it, I'm so sorry, or greater than or equal to, you shade above. So those are things we need to know. A solid line, a dashed line, and if you shade above or if you shade below. Shade above or shade below. So here's what they gave us. Trent's going to be participating in a long bike race soon. He needs to ride a total of at least, that means greater than or equal to, 288 kilometers today. He plans to do this by riding multiple laps on the Highland Loop, which is 24 kilometers long. So 24, and put H for Highland Loop. Plus, he's doing the Pinehurst Loop, which is 36 kilometers long. 36 P. If X represents the number of laps in the Highlands loops, oops, let me change that. So 24 says X represents Highland, plus 36 says Y represents the number on the Pinehurst loop. Which inequality can be? Write the inequality that can model this scenario and graph it. Greater than or equal to 288. So first of all, here's the inequality in standard form. At least means greater than or equal to. We know my Highland loop is 24 kilometers long. Plus, I know my Pinehurst loop is 36 meters long. Once again, I said at least means greater than or equal to 288. And then I just changed it in X and Y because it says here that X is your Highland loop and Y is your Pinehurst loop. So in general, that's what it is. If I want to graph it, I need to change it to Y equals. So I need to get the Y by itself. So we have 24X plus 36. Or do y'all want to do cover up? Let's do cover up method. I can show you both if I need to. I'll show you both. Okay, so we have 24X plus 36Y is greater than or equal to 288. I want to get the Y by itself. The opposite of a positive 24x is minus 24x to both sides. So you have 36y is greater than or equal to negative 24x plus 288. We need to get the y by itself, so we divide by 36. If we divide by a positive number, our inequality, the sign in the middle does not flip. So y is greater than or equal to, let me see what negative 24 divided by 36 is. We clear that. Negative 24 divided by 36, and I'm going to change that back into a fraction because yikes, is negative 2/3. So y is greater than or equal to negative 2/3 x. What's 288 divided by 36? Ooh. 288 divided by 36 is 8 plus 8. Okay, so here's what we know. My y-intercept is 8, so I'm going to go ahead and put a point on 8. My slope is negative 2/3. That means we're going to go down, and this is rise over run. Negative 2/3. Remember, rise, just how much you go up and down over your run, how much you go left and right. So I'm going to go down 1, 2, and then I'm going to go right 1, 2, 3. Here would be my next point. Okay, so here's what we know. If it's y is greater than or equal to, first of all, solid or dashed? Solid because it has or equal to. If it's greater than, do we shade above or below? Above. So our line, using my badge to just kind of finish it up, is going to look something like this. And then you shade above. So it's a solid line, we shaded above the line because it's greater than or equal to. All right, let's see if I can get these last two done before the bell. All right, this one is already in slope-intercept form, so we don't got to mess with it. We have a y-intercept at negative 8. So I'm going to put a point at negative 8. Well, I know my slope is 2. That's technically, if I want it as, so if I do rise over run, let me backtrack. If there's no denominator, if it's not a fraction, the number on the bottom is a 1. So it means I'm going to rise 2, up and that means go up and down, 2, run, left and right, 1. So I'm going to go up from here, 1, 2. If I go to the left one like this is going to make my line go like this, which is going down and negative. We have a positive 2 slope, so we're not going to go to the left 2. If I move it to the right, the left one. If I go to the right 1, that would put my dot right here. Is it going up with a positive slope like we want? Yes. Up 2, right 1. Up 2, right 1. Up 2, right 1. You get the idea. And so if I'm looking here, it says less than or equal to, so solid or dashed. Solid because it has or equal to. So let me go get that solid line in here. And if it's less than, are we going to shade above or below? Below. And if you're like, I don't know how to shade below, literally from your line, draw an arrow pointing down. That's going to tell you where to shade. If you have to shade above, draw a line from the arrow pointing up, and that'll tell you where to shade. Okay. So for this one, it's in standard form, which is like this one was. So I'm going to go back to this one too and talk about it real quick. So you can always convert it into your y form in slope-intercept, or use your cover-up method. So I'm going to talk about cover-up method on both of these, and let's see if we can finish up before 7th period comes rolling in. Okay, so let's say we want to do cover-up method. If I cover this up, I have 24x equals 288. I'm going to write that over here. 24x equals 288. If I'm solving for x, we're going to divide both sides by 24. What is 288 divided by 24? 288 divided by 24 is 12. So x equals 12. So that means I should have an x-intercept at 12. That just shows how off my line was. Gosh dang, y'all. So pretend my line actually hit the x-axis at 12, yeah? Okay. For my y-intercept, I would cover up my x. I have 36y equals 288. 36y equals 288. Divide both sides by 36. Y would equal 8. That means I have a y-intercept at 8. So you could have plotted those 2 points and then sketched your line, instead of doing all of this work of converting, whichever one you prefer more. So same thing on here. We can either convert it, or we can use our, oh my gosh, words. I'm panicking because it's getting so close to the bell. Or we can use our cover-up method. If you are a converting kind of person, 3x minus 5y equals 20. Not equals, less than 20. Yikes. We want to get the y by itself. The opposite of a positive 3x is minus 3x to both sides. Negative 5y is less than negative 3x plus 20. We want the y by itself. We divide by negative 5. If I divide by a negative, my inequality sign flips. So this is going to be y is greater than, trust me on this, it's 3/5. If you plugged in negative 3 divided by negative 5, negative 3 divided by negative 5, and then hit the fraction button, it will give you positive 3/5 x minus 4. So I have a y-intercept at negative 4. And plot that point. My rise over run is 3/5. 3 over 5. Rise over run. So that means I'm going to go up 3. 1, 2, 3. And if I want it to be positive, I'm going to go to the right. 5. 1, 2, 3, 4, 5. I'm going to have a point here. Up 3. 1, 2, 3 over 1, 2, 3, 4, 5. There's the 6th grade bell. First of all, okay, before I draw my line, because it's greater than, is it going to be solid or dashed? Dashed. It does not have or equal to. And it's greater than, so we're going to be shading above. So I'm going to take my badge here, make a dashed line. We're going to shade above. There's my sketch. If you're someone who wanted to try to do the cover-up method on it, you could have done that. So if I cover up this, I'm left with negative 5y equals 20. Divide by negative 5, y equals negative 4. Plot a point on your y-axis at negative 4. This one would be x equals 20. 3x, oh my gosh, equals 20. Divide both sides by 3. X equals, you see what that would be, 20 divided by 3. 20 divided by 3 is 6 point something, so it's going to be some point after 6. So on my graph, it's like 6.6 blah, 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 blah. I would put a point on 6 point something and then sketch my line. Either one would have worked. All right. Get it, got it good, y'all. Also, here's the only one real quick. The only benefit to converting it instead of doing this, because yes, doing the cover-up method gets you your x and y intercept, but if you change it into your y form, slope-intercept form, then you know for sure whether you're shading above or below. If you want to look at the standard form equation, guess what? If your y is negative, your sign's going to flip. So even if you just did the cover-up method, if your y is negative, it's going to be greater than. You could do those 2 points, shade above. Same thing on this one. You could have done your cover-up method. On this one, my y is positive, so it's not going to flip, so it would still have been greater. So even if you don't convert it, you can figure out if you flip or not, depending on if your y is negative. Good luck.